AI feels magical, right? Tools like ChatGPT, Claude, Gemini, Copilot, they write the essays, they write even the code, poems, going artistic. But here's the truth. At the heart of it at all, they just do one simple thing very well. They predict the next word accurately. So, if you want better answers, you have to give better instructions to extract those good answers out of it. That's exactly prompt engineering. In this lecture, we'll break it down from the ground up what LLMs are, how do they actually work, their limits, and how you can talk to them effectively. Now, first, what are LLMs? Well, the word LLM, as you might know, is a large language model. Now, let us try to understand this word by word. First, it's large. Now, why it's called large? Because they are trained on massive data sets. You can think all the books, all the websites, articles, code bases, way more text than any human could ever read. That's what they have been trained on, and hence the word large. Second is language. Now, LLMs, they work with human language, not just English, but many languages, as well as many programming languages too. Third, model. Now, in math and computer science, a model is just a system that learns patterns from the data. So basically, an LLM is a pattern recognition machine that is trained on language at scale. This pattern recognition machine basically represents a model. The language represents the second word, which is the language that they have been trained to work upon. And scale represents large because they are trained on massive data sets. So you can just think of LLM as a pattern recognition machine trained on the language at scale. That's what the LLM is. Now, I would like to add one more section here just for understanding and to see the contrast on how the LLMs work versus how the humans work. So let us try to reason from scratch. When humans read words, we try to connect them to meanings and experiences. For instance, if I say the word sunset to you right now, you perhaps might imagine the orange sky, maybe the sound of birds, maybe a memory. When LLMs read such words, for example, the sunset, they try to connect them only to patterns of what came before in the training data. Let me explain what I mean by this. So, when you say sunset, they don't see a sunset. They just know that the word sunset, based on the historical data that they are trained on, it's often followed by in the West. So sunset is often followed by in the West based on what I have seen in the past in the data. So this is the gist of how they essentially predict the next word and generate the next word. So to summarize, how do they generate the text? They take your input, they break it down into smaller pieces. And these smaller pieces, we call them tokens. Second, they look at all the data that they have seen. And then they ask, what is the most probable next word that can occur after this? They find it and they spit it out. Then they just repeat it again and again, building the whole text line, one token or one word at a time. Let's take an example. Let's say you type, the cat is on the LLM predicts mat. Now it has, the cat is on the mat. Now, if you want LLM to start generating the next words in this sequence, then perhaps it could generate the most likely words. It could be and, then it, then is, then sleeping. So the cat is on the mat and it is sleeping. That's it. It generates the next word just based on probabilities, just based on math. No deeper understanding, no visualization, no experiences like humans do. So if I have to summarize whatever I said above, humans, they understand, they feel. LLMs, they predict. Now, two key terms, very, very essential in the context of all the LLMs that you'll work with. First is the context. Pretty straightforward. No sentence makes sense without the context. Example, he scored a century. Now, what does this mean? Who is he? Which sport is this? What's the context essentially? So same with LLMs. The more useful context you give them, the more accurate they will generate the output for you. Second term, tokens. Now, computers don't read like us. They can't handle words as is. So they try to split whatever you enter into tokens. Tokens are essentially tiny chunks. For example, there's this big word here. So this, during the processing by the LLM, would get chopped down into super, cali, fragile, etc. Now you can think of these tokens as just Lego blocks. The AI, the LLM, they doesn't see the whole house, but the small chunks or the small bricks of the whole house. One thing to keep in mind, LLMs are only as good as their data that they are trained on. I'm assuming there are no surprises here. So basically, whatever the mathematical model that you're using is only good as the data that you train it on. If the data is biased, the outputs are bound to be biased. If the data is limited, the output will be limited. If the data is diverse and high quality, the outputs will be richer. So simply put, there is a garbage in, garbage out principle. Whatever you put in the data, you're going to get the same kind of model back. Imagine if you trained a model just on Reddit comments, the answers would be chaos. Just kidding. So let's come to the crux now. Why prompt engineering? And then we'll see what are the best practices. So first, why prompt engineering? Now think about this. If LLMs only predict and what you can provide is only the input, then definitely you need to understand what's the best way to provide that input so that you can get the best output from that LLM. So think of prompt engineering as giving instructions to an LLM. So instead of you saying like, make me something nice to eat, you should know that you have to communicate it better. Basically, you have to engineer your query better. So instead of that, you can say, make me a pasta with tomato sauce, no cheese, and serve hot in 10 minutes. Now, you are most likely to get exactly what you want in the second prompt. That's exactly prompt engineering is. And that is why it's very, very important. It teaches you how to ask the questions in the right way, essentially turning your vague wishes into precise instructions. Now, let's try to take a look at some of the best practices that are very, very essential to keep in your arsenal when you're talking to an LLM. First, be clear and specific. Now, remember this, that AI cannot read your mind. You can say, fix my code. It's a bad prompt. Perhaps a much better prompt would be, fix the syntax error, ensure order nlog in runtime, and make it Python 3.10 compatible. So we are trying to gain more clarity with our questions and trying to be more and more specific. Second, you should give the context, but you should provide just the enough context and not overload the LLM. Now, this is where most of the people make mistakes. Definitely, without enough context, no answer would make sense, but too much of it, and be prepared to accept that model will get overwhelmed. For example, you don't want to paste 1000 lines of code. You just have to give the 20 lines around that bug. So how I like to remember and how I like to kind of feel it is, you should provide a focused context. You don't want to dilute the attention of LLM to something unnecessary. Third, break down the tasks into steps. So complex tasks are actually quite difficult to be solved even by humans. How do we communicate to a human to solve a complex task? We basically try to give step-by-step instructions to it. So nothing changes with an LLM as well. So instead of saying, fix, optimize, and test my code, you can say, step 1, fix the errors in my code. Step 2, optimize the error-free code that you got from the previous step. Step 3, add unit test to the optimized error-free code. So simple steps making up the whole complex program. So next, and quite important one, role prompting. So here, we try to assign a role to an LLM to get better answers. Examples. Scenario 1, I say to an LLM, explain blockchain. Quite generic. Scenario 2, I say to an LLM, you are a university professor. Explain blockchain to a 12-year-old using simple analogies. Essentially, you are giving a role to an LLM, and that role captures a lot of things. In the context of coding, one example could be, act as a senior Java developer reviewing my code and suggest improvements for readability and performance. So you are essentially giving an LLM a role. Different roles, different actors, and different kind of performances you can expect. Next, specify the output format. Now, always try to specify in what type or in what form you want the LLM to spit out the output. Without it, it would be ambiguous for it to know. It could maybe give you paragraphs, it could give you bullet pointers, it could give you a table. So you have to explicitly specify what kind of output format you need. So instead of saying just respond with text, you can say perhaps respond with a JSON file containing keys. It also contains fixes, tests, and optimization summaries in a couple of lines. Now, next strategy, few shot prompting. Now, what is this few shot prompting? So it basically means that if you give a few examples in your prompt, they would latch onto the pattern and then continue it. Example, let's say you want the LLM to correct some grammar in your sentences. So what do? you provide a couple of examples. You say, incorrect, he go to the school. Correct, he goes to the school. Second, you provide another example, they is happy. The correct is, they are happy. Now, with these examples, you ask the question, fix, she have a car. So essentially, you are trying to provide some examples. And with those examples, it's trying to learn. It's trying to basically understand the pattern. And based on that pattern, it will then provide you the answers to your queries. That's why it's called few shot prompting. So basically, you try to show it how it's done and just don't tell it. Next, self-critiquing. Now, testing always reveals the truth. The cool part with LLM is that you can tell the LLM to critique its own answer and then improve it. Most of the time, it actually catches its own mistakes. So for example, you can say, write 5 unit tests for this function, including empty input, null values, blah, 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 whatever that prompt is. And then you can also add, critique your own answer above and also suggest one improvement. So basically, it will try to critique itself and recursively improve itself. Quite powerful. Next, try to control the length and the style. It's a well-known saying that the constraints guide creativity. Same thing applies here. If you don't specify, the model might perhaps, write an essay when you only wanted a summary. By giving length, style constraints, you force it to a tailored output. So some examples, you can say, summarize this article in exactly 3 bullet points, or perhaps explain binary search like I'm 10 years old, or write a 100-word bedtime story about a rabbit ending with a moral. So you're trying to control the specs, the configurations, the length, the style, etc. And these constraints would basically guide the LLM towards creativity. Next, iterate and refine. Now, you know that the first drafts are rarely perfect. No model would give you the best answer on the first try. The key is to iterate, tweak the wording, add details, break into steps. Think of prompts like code. Basically, you're trying to debug them until they work. Examples, iteration 1, perhaps you could write a prompt, summarize this article. Too vague. Iteration 2, you can write a prompt, summarize this article in 5 bullets under 10 words each. Much clearer. Iteration 3, summarize this article in 5 bullets under 10 words each, focusing only on the business impact. Now, you have got what you really wanted. So, refining step by step gets you exactly what you want. Prompt engineering isn't a one-shot magic. It's basically a loop of improvement that a machine and a human can work with collaboratively. Alright, so we have just covered these powerful best practices. Feel free to experiment and find even more. But keeping these fundamental ones in mind will instantly make your prompts sharper and help your AI to cooperate with you much better.